Okay, here we go. Hey Mike, how's it going? This is Logan. What we wanted to video was a kind of theory that we came up with. You'd written something about, when Logan had asked, why does this work? And you'd said something to the effect of, it's just a pattern, somebody noticed it, and they wrote it down. And we have a feeling you already know what we're about to say, but I think what we were asking, because I had the same question, why does this work? We think we might have actually come up with a reason why this works beyond just the pattern explanation. So Logan's going to start. Logan's going to start.
So, so our theory is that, well, when there's two piles, it's obvious that when you have 7 and 13, you're trying to mirror it. So if you have the first move, you take 6 out of the 13, so now it's 7 and 7. And from there on, you just mirror the other person's move, whether they take 2 or 1. No matter what you do, you just mirror their move, and then you'll be able to win. And if you draw it out in like piles and powers of 2, it'd be 1, 2, 4. And each time they take one of the groups of powers of 2 from one side, and they make this they make this 3, then you just take the 4 from the other side and make it 3. You're trying to even the piles or even the powers of 2 on each side. And we think that this theory happens on a much larger scale with multiple piles too. It's just harder to see than if you having just 2 piles. Like, for example, in the 5, 7, 10. 5 is 1 and 1, 1 and 1, 4. 1, 0, 1. 7 is 1, 2, 1, 4, 1, 1, 1, 1, 1. And 10 has 1, 8, 1, 1, 2, 1, 0, 1, 0. And so we see that, obviously, that there's 2 2s, 2 4s, and 1 and 2 1s. So there's an even amount of everything except for the 8s. So the only way to set it to 0 is by taking the 8s pile, all of the 1 8s, and making this 2. And that, from there on, you're making them even. So from then on, whatever the other person does to each side, you just mirror their move, and you're able to win. Like, you're able to win by that way.
Yeah, and I think...
Right? Here,
no, absolutely. And this also, the thing that we also noticed, just before we turn on the camera, was that the exclusive OR works.
Yeah.
Because this is 1, 0, 1, this is 1, 1, 1. If we exclusive OR those, the result is 0, 1, 0.
Which is 2, yeah. You take 8 from that, 2.
Right? So if we take that 8 away, you're left with the 2 right there. And that's, of course, the answer if you want to win the game. So our theory is that that's really what it is for any number. You can kind of break it up into its powers of 2.
Yeah, and even if they don't take a power of 2, let's say they take like one of the 2s here, you just do the same thing here.
It still works.
Just a mirroring thing that is just harder to see when you have 5, 7, and 10 because it doesn't look like 5, 7, 2 doesn't look like it's even in a sense almost, or maybe it does.
Yeah, I mean, it's a little more complicated.
Yeah,
I think it's a little more complicated than that because, let's say they took, if they took 3 from here, right? Okay, now we're in a situation where these match. Oh, actually, it does work.
Yeah. What I'm just realizing now is that, does it always, so like you said before, almost like the 5 and 2, when it's 2, 5, 7, 2 plus 5.
If you can figure, maybe that's what we were talking about. If you can figure out what's being taken from, like you take 3 from there, okay, think of that as taking 3 from a 4 pile, you need to find one else, another that has a 4 pile, and take 3 from that 4 pile.
Yeah.
Right?
Yes, exactly, yeah, so whatever it's still, everything still works. Exactly, right?
So maybe that's the trick you were trying to say all along. But it seems to us that there's like a reason, that it's not just there's a pattern, but there's a reason. Maybe that's what you were trying to say.
Something with like the powers of 2, like Justin, do you want to show the 5 with powers of 3?
Well, then we tried it with, just in case I was thinking, okay, is base 2 special? So we did it, the same problem, 5, 7, 10 in base 3, and we don't see it working. We just don't see it working. So we've got, 3, 1, 1, 3, 3, 1. I think it's the on-off thing. It's the fact that in binary you're just on or you're off.
2, I got you.
Whereas here, I don't know what you are. And I think, Mike, you said something about you can, in fact, do the XOR on other bases, but it's sure a lot easier to understand in base 2.
Yeah.
I don't see how it's going to work in this base. Okay, and the other piece that we had was I'm wondering if base 2 is somehow special because of, what did you say they were, like it's a number trick?
It's a number trick. Like you know those birthday cards where they use binary, that on each card they have all the numbers, 1 to 31, and base 1, like 2 times 2 to the first, and then 2 to the second, 2 to the third, and then you can guess each of their birthdays because like the numbers on the card are what matter, because the binary numbers, they don't.
Like this is all the odds because all the odds have a 1 in the ones digit.
Yeah. And
then this is like, what is this like?
It's 2, 4.
Is it all evens?
It's all the.
Which ones have the 2's digit have a 1 in them? Oh yeah, it would be the evens.
Yeah, because you can just look at the first number, which is the like the.
No, except 8 wouldn't be on there because 8 is 1 0 0 0. So that doesn't have one in the 2's digit.
So would you take out all?
You'd have 10. You'd have anything that's
that
2 more than. Anyway, you get the point. So there's a 2's, and then everything that has a 1 in the 4's digit, and so on, and then I can tell what the number is that they're thinking of. Like I can hold up each card.
Yeah.
You've probably seen this.
Yeah.
And it's like, and all I'm doing is adding. Like if they say yes, 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 I know they have a 7. You know what I'm saying? And if it was yes, 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 and then they say yes on the 8 card, they have a 15.
Yeah.
And if they say no, 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 yes, they have a 16 because 16 doesn't appear until the 4th card.
Yeah.
So I feel like somehow that property of binary numbers is why this works. Is there anything else that you want to say to Michael?
I mean, thank you. Yeah, this is definitely really cool. I mean, yeah, I think just visualizing it really helped Justin and I. Helps to see like, oh, like you're just the base 2 like number. It's cool.
It's fantastic, and I think actually, yeah, I mean, Mike, I think if we're right about, because I hadn't actually seen that before, where you were like, you took away 3, and you took away 3.
Yeah, yeah.
If you just know where you're taking it from, like if you took the 3 away from another one that didn't have a 4 in it, you'd be stuck.
So
right?
What happens if they take like the 1 from here, and then there's all these other ones they can take from? So.
Oh, so okay.
Yeah.
So let's say we're in this. So put the 1 back.
Okay.
Wait a minute.
Yeah, so we're gonna draw.
Okay, you probably don't need to watch this.
Yeah.
Thank you very much, Mike, and we'll be in touch. Thanks, buddy.